Well, hey there, everybody. Welcome to Astronomy Daily Live. It is 2 hours UTC. You can call me Cosmic, and welcome. Come on in. Hey, hope everybody's doing well out there in the universe and the world. Everything's good here. Had a little windstorm actually blowing through here, so blew up the dust a little bit, that kind of stuff, and actually blew in some nice cool air. So yeah, feeling really nice. Actually, pretty clear. So yeah, I will start out the live stream by reminding everybody that there's still I would say a 50-50 chance that I'm not going to be doing a live stream tomorrow. Going to be doing a star party for some coworkers and some friends, and that is going to completely um, interfere with any of the star party plans. So yeah, I would say at this point there's a 50-50 chance of success and or failure. So yeah, what I'll try to do is sort of make a final decision, probably like around maybe 0 hours UTC or so, um, and maybe I'll post a video or something. Um, I'll go outside and post a shorty, just saying, you know, no, it's not going to be on today. If you don't hear anything at all, then you can just assume that it is going on as usual. So come on in, friends, for now at least. Join the ever-growing circle. We also like to call this, like a virtual porch, right? Where we just sort of, it's, think of it as sort of the end of the day where we're just sort of relaxing, nice breeze outside. It's starting to get a little bit dark. Everything's sort of calming down for the day. The end of a busy day. Most of our days are pretty busy, one way or another. Whether they're busy just inside of our heads or if they're actually busy. I think everybody stays pretty busy most of the time. So hey there, Tom. Nice to see you in the chat. Nice to see you. Crystal is also on the chat and on time. Pretty good. Yeah, I was actually, and this is just a like a complete failure on my part, right? I planned on having a star party in about 24 hours, right? And I had planned that around the fact that, at least in my head, right, it was just a few days after new moon, and I'm like, wow, that's going to be a great view, right? We'll pull a telescope out and we'll have the moon there, and that'll be really cool because there are going to be some people who have never ever looked through a telescope before ever, and I definitely thoroughly enjoy those kinds of things, and so yeah, I had it all planned, and then yeah, for some reason I realized that it's like, no, we have another week. We have another week until there's sort of a visible moon. This coming week, right? This coming week, we're going to be going through new moon. Atta, hey there, nice to see you in the chat. Yeah, that I heard about Space Fab from last night's live stream that Fraser did with Skylius, and it's these same guys. They're sort of all in this group, but yeah, they were talking about a space telescope that they are going to be launching on a Falcon 9, a SpaceX Falcon 9 rocket. Now that's not going to be the primary payload. It's going to be a CubeSat, what's called a CubeSat, and a relatively large one. The the units for a CubeSat size. And let me adjust this. There we go. The units for a CubeSat size is so-called 1U, and 1U is 10 centimeters wide, 10 centimeters long, and 10 centimeters deep. So that's a 1U cube, right? This telescope that they're actually, planning on launching next year, right? Is going to have, now what he said in the live stream was a 6-inch, but if you look at SpaceFab itself, they're talking about an 8-inch, So that's exactly the same size as my scope here, and that they are going to be putting on an 8U CubeSat. So sort of imagine eight of these cubes, sort of shaped in a particular way. They're going to have solar panels. They're going to have some kind of guidance and navigation, and I guess the idea is that you're going to be able to operate these things with your smartphone, right? And somebody asked him, what the chargers are going to be for using that scope, and they said, and I completely agree, it's probably too early to really know, because they're still, developing it. They're starting to work on things and all that. So they didn't have any firm numbers, but he did throw out a figure which was $25 a minute. So is that a reasonable cost? To charge somebody to use the telescope in space? Yeah, maybe. This telescope just isn't going to be used for all the astronomical things. They're actually going to be looking at the Earth too, and I think it sort of sounds like that's their primary thing, right? Is that they're going to be looking at the Earth. They're going to be looking at farmland and oceans and forests in a bunch of different colors simultaneously, and there's a lot of information when it comes to color, right? That's a spectrum, so I think their primary source of income, right, is going to be that. But they are going to have the capabilities of, turning it around and looking at the sky in both the visible and the ultraviolet. Right now, down here on Earth, right, we can't see much in like the ultraviolet. It just doesn't get down here, right? That light is absorbed and or scattered by the atmosphere. So to have, some kind of device above the atmosphere, you can actually see things towards the ultraviolet, and that's very, very interesting. Anyway, so yeah, and Uncle Bill, I don't know about any kinds of limitations in terms of sizes. So I mean, you would probably know that better than I. But I think Gesundheit. Hey there.
Forget about me?
No, I didn't forget about you. I was just getting around to you. But there you are. Bobby jumped in with a big whatchamacallit, yeah, a big huzzah. So what's going on, Bobby?
Nothing much. I'm in multitasking between Tim's wife. He's about to go off right now, and you.
Learning things from Uncle Bill. I can tell. I can tell. But you're only watching 2 at a time, so you're still a rookie. So yeah, it's that's an interesting thing, and it looks like this space fab thing is going to go, and yeah, for $100, maybe I'll get 4 minutes of telescope time. Could be interesting. I don't think there's that there's anything I would really find too useful for that. But who knows? Who knows? Interesting. I think it's great. I think it's great. I think we need, like I said many times, I think that we need a lot of space telescopes up there. Now, an 8-inch scope has its limitations, right? But if that's what it takes to sort of get started and prove the concept and all that, I think it's great. What I want is like 100 Hubble Space Telescopes up there. Then we can get some work done, right? Because at that point, ground-based astronomy is well, I mean, I can't say for sure, excuse me, but ground-based astronomy would basically be over, right? I mean, it's like, why bother, right? All the adaptive optics, all that work, all those years and years and years of work, yeah, it's hard. And yeah, if you're the investing type, yeah, I think it's, I mean, you want to look at their business plan, and you want to look at their model, and you want to look at all the projections, all that kind of stuff, right? But I think there's some interesting possibilities there. I don't think that it's necessarily going to be incredibly lucrative, but I think they will keep that telescope pretty busy for sure. I mean, if nothing else, looking at the ground, that should keep them busy too. But I would think that the astronomical community may be able to sort of tip those scales and have it pointing out instead of in, right? And that's I was thinking about Buckminster Fuller a few hours ago, and that's one of the things that he talked about a lot, right? Is that they're really in space, right? And we are in space, right? The Earth is in space, right? It's not as if we're not in space. We're already in space, but in space, right? There is no up. You can't point to up, and there is no down, right? There is no down. What there is, right? In sort of a relative sense, is that there's an in and there's an out, and that's about it, right? So yeah, he oftentimes tried to encourage us to change our language a little bit. Things like sunrise and sunset, absolutely drove him insane, right? The problem is that, as far as I know, he did not come up with any other word, right? And my opinion about that is that it's like, well, yeah, sunrise and sunset is very misleading, right? It's very misleading, but I think I think that everybody sort of understands. They sort of know what is going on. Hey there, Gilles. Gilles has shown up in the chat. Nice to see you there. Hey there, Tim. Nice to see you too. I noticed that you were.
Hey,
Hey, and there's Bobby too. Say hi, Bobby, so they
hey,
can
what's
see you.
up, everyone?
All right, cool, cool.
Tim just finished with his live stream and decided to come and join with us. So Jill's too.
I think that's extremely, extremely awesome. So, yeah. All right. Well, cool. Yeah. Well, Atta, one device in space like this is not going to do anything to ground-based observations. I mean, it is just an 8-inch scope. So there are limitations there, right? I mean, ultimately, you just can't see very, very faint things, and not that really is a limitation, but the fainter you can see things, the more you can usually see, and when you're trying to gain some kind of an understanding of some kind of population, right? Well, you want to be able to sample as much as you possibly can. And I mean, it comes down to time, right? I mean, you could take a long exposure, right, for days and days and days and days and days, right? Because in space, theoretically, right, you don't have to stop, right?
And I just say, Conjaya! Here goes the Hip Raptor. What's up, Hip?
Hey there, Hip. Nice to see you in the chat, too. Now, Hip, I think it was you that coined a phrase. It was something porch, right? Something porch. And you said it in the chat. Now, this was like, I don't know, a month ago or 2 months ago. I don't know. But I've been calling it the virtual porch. And that's not quite right. But, Hip, I think it was you that called it something else, and if you can remember what that is and post it in the chat, I am going to write it down. Right? I'm going to write it down. You know what? Maybe I did. Oh, hold on a second. Now that I'm thinking of it, maybe I did write it down. Yeah. Did I?
Hey, so that's why Jills and Tim is there. Maybe you should teach them how you can still get Google Hangouts and stuff like you always been doing.
Teach them how to do it.
How they can still get Google Hangouts and still stream it off of YouTube and stuff.
Oh yeah. They've been. I think Tim is doing that, as far as I know.
I'm not sure Tim's doing it, but I think they have been using their YouTube preferment. I think it's called I forgot what it was called, but there's also OBS as well. They've sometimes been using as well.
Yeah. Well, if I could, I would be using the OBS too. I don't have the horsepower to run it. So the OBS is absolutely fantastic. And as soon as I have some horsepower here, I am definitely going to switch to that, because it's absolutely fantastic in terms of being able to show you things, and I think the interaction is really, really nice too. But Google Hangouts though is really, really easy to use. So I mean, there is nothing to it at all. You create an event, and then you start it, and here we are. So yeah, it's as easy as that. So all right, here let me look at the chat here. Spaceports? No, it wasn't Spaceports. It was something really, really nice. But yeah, if you're driving, I would encourage you to continue to do that. so yeah. So anyway, this is the virtual porch. So if you have a consumable on hand, like I usually do, right? Cheers.
Yeah. I don't know why the DMV won't let me drive. I mean, I can drive straight. Going straight is easy, but I did try to do a turn one time, and around the urbanized Morgan City, they used to have something called the NGC. I would have almost hit that statue. You talking about? Oh my gosh, we're gonna be owning them some money. Oh my gosh.
What it takes is, just like with almost everything else, right? It takes practice and it takes patience. You got to have patience with yourself, and you just have to practice. Just have to practice. It's but it is a very much a multitasking kind of a thing. I mean, you've got to pay attention to lots of things at the same time, but over time.
That's true when you're biking as well. Yeah, you really got to pay close attention.
Oh, absolutely, absolutely. So yeah, it's at first it's a little bit hard, but over time it gets easier to a point where, and this can actually be dangerous, right? In that you stop paying attention to your driving. You start thinking about things, and your mind just sort of wanders, right? Wanders around, and all of a sudden, you sort of snap back, and it's like, wow, I've been driving for 10 minutes and I don't remember anything. But I think after you do it for a while, a lot of those things are pretty automatic, right? You're paying attention to things sort of instinctually. So yeah. And yes, turning is a skill that is required to have a driver's license. That's an absolute fact.
Well, the reason why they won't let me give me a driver's license is because of my mental disability.
Well, and that is for your safety and the safety of all of us, right? So yeah, I mean, if you can't, you can't. So be it. All right. Well, cool. I wanted to. Yes, we actually could call this a raid. This could be my first raid. So happy raid. Yeah, very, very cool. Let's see. Just looking at the chat. I wanted to. Yesterday we sort of skimmed over these things that we call star parties, and I just guess I wanted to talk about those a little bit. If you don't know what those are, you might think that they are something that they aren't, right? A star party is not your typical party, right? There's no, there really aren't any kind of the typical, wild and crazy times. There's no loud music. There's actually, yeah, there can be a lot of discussion, but it's usually very, very dark, right? Because we don't want any lights, right?
Hey, Lady K.
Hey there, Catherine313. Nice to see
I
you.
hope we
In
don't
the
need to
chat.
call the cops yet with all those raiders coming in.
Yeah. Um, so typical star parties are done, sort of out in a remote place where it's dark and quiet. Doesn't always have to be there. They can be done, like at schools. They can be done, you know, um, yeah, pretty much anywhere. But
Now, would
typically,
anybody would have beer in a star party, just like Tim Robinson suggests?
you know, there really isn't anything wrong with that, right? I mean, as long as you're careful. No, I don't think there's anything necessarily wrong with that. But the main purpose of a star party is to do exactly that. We're going to party with the stars, right?
Now, what kind of refreshments we're going to see at a star party?
Typical refreshments are pretty not too exciting, right? We're going to have the
Oh,
regular
like,
kinds of, like sodas and water, and that's really about it. Because the main focus, right, is to take these scopes, right? These guys over here, they're all these scopes right there, right? Set them up.
I wonder if it's just drinks at a star party, or there's like fish and chips and all other stuff.
Yeah, sometimes there can be some snacks. Yeah. Usually, there are many different kinds of star parties too, right? There's two main ones though, right? If you're part of some kind of astronomical society, right? Some kind of astronomy club, right? Then that club can sort of have its own events, right? Where they go out to a dark site, and they bring their telescopes or they bring their friends or whatever, and it's primarily just to set up the scopes and look, photograph, and just socialize with your fellow club members.
And speaking of star parties, I didn't stay long for that Sky Ellis's and Fraser Kane's star party very long because what happened? My Twitch app on my Roku, it was saying it's on, but it will not let me watch it for some whatever reason. So I watched it a little while on the computer before I said, "Well, I'm just going to hit the hay."
Yeah, I think I was on there for maybe about an hour or so. I think so, but yeah, that's anytime past like 9 p.m. or so is just way past my bedtime. So so yeah, I start to dive quickly. Past about 9 or so. So anyway, so that's sort of one kind of star party, sort of a club star party. The other kind is a public star party,
And
where
looking at that, if there ever was one with beer, we would definitely be seeing the Andromeda Galaxy or the Pegasus Galaxy, one of the two. We'll be
yeah,
seeing galaxies or out of the cosmos and stuff.
it's all you're going to see is double stars and triple stars and quadruple stars. That's all you're going to see. Yeah.
And then we're going to see a series of neutron stars as well.
Yeah. So yeah, public star parties are pretty fun because as the name implies, right? It's for the public. It's not. It's more like astronomy club members will go out, set up their scopes, and then invite the public to come out and look, right? And most members of the public, right, have never looked through a telescope. So they have absolutely no idea what to expect at all. And so, that is a delight, right? I mean, that's a delight for, the new person, seeing Saturn for like the first time, or seeing
I just
the
want to let
moon.
y'all know you did spin, but you're back. So I'm not sure. I think Tom's got to refresh and stuff.
Oh yeah, all right. Well, that's how it goes. I'm gonna. Why don't I turn on my smartphone here so I can monitor these shenanigans here a little bit and make sure that I don't freeze up too much. But we're a very, very casual group here. At least I hope so. So, when things go a little bit off, we shrug it off. Looks like it's going now. Although I'm not hearing any audio. Oh, because I've got myself turned down all the way. Yeah.
I usually put mine all the way down to 0 when I want to went onto the channel on my phone.
Yeah. So so public star parties are really, really fun because you get members of the public, like I said, that may have never ever looked through a telescope at all, and that is, it's such delight for both a member of the public and for instance me, to be able to show off those objects for the first time ever. It's absolutely great. And there actually is a third kind, and that's like a school star party. So you can invite students, right, or kids to some kind of a location and take a look through the telescopes. And
Tam Robinson, I have a lovely view, dark of the night sky at the rear of my house, which is south facing.
Sweet.
Ottawa lives near an observatory called the Muddy Run Observatory that often holds star parties for the public. Those with scopes can set their own outside.
Cool.
Uncle Bill, I think he had to refresh as well. He did worse than Span. And Jill says, I really miss dark skies. Here in Montreal, magnitude of the weakest stars is visible by a +3.
Yeah. Luckily, in most parts of at least the Western world, right? You can drive 30 minutes and be in some pretty dark skies, regardless of where you actually live. I'm lucky enough here, right? I mean, it's by choice, right? But I live in a very, very, very dark part of the southwestern United States, and I'm surrounded by major observatories. So they're not going to put their big boys in just some random spot. They're going to put the largest and best telescopes in the world in a really, really dark and dry spot, and that is right here. So the other thing that I wanted to talk about a little bit is about this idea of charging people to to look through a telescope, and I sort of on principle, I have always been, it's like, no way am I ever going to charge somebody to look through my scope. Not a penny, right? Not at all. Photons are free. I'm just sort of providing a means to collecting a few more and showing them off. So absolutely no way at all. And for a pretty long time, and I mean even now, right? I sort of have a little bit of a problem with people charging for those kinds of things. But, you know, I guess the thing that sort of overrides all of that for me is this sort of this free market mentality that I have, right? I mean, if people are willing to pay, then and you know they're getting satisfaction, then that's okay, right? And you know, if the astronomer who you know is charging is making a few bucks off of this thing, you know, I mean, it pays some bills, right? It sort of you know keeps them motivated, right, to do this. So I don't, you know, I'm starting to change my tune a little bit on that. Sort of maybe being a little less judgmental about people who do that. I know the local astronomy association here actually has two different things. They have, you know, their public star parties, which are free, and then they have paid star parties, which is sort of like a private party, right? Where you know, say that somebody's having like a birthday party, right? And they want to set up some scopes, and you know, they want to have.
You're talking about having a paid star party or a free star party?
What's my opinion?
Yeah.
I think that people should be able to do whatever they want. So you know, if if they want to charge and people are willing to pay, then I guess my attitude is go for it, right? Now, you know, if somebody, right, say that there's two astronomers, right? One astronomer charges and the other is doing it for free.
Yeah.
Right? And basically, I'm doing the same thing, right?
Yeah, check the chat too.
Check the chat. Yeah, I am. Yeah. Yeah, and you know, I think Atta, that giving him some competition, actually, you know, he may not change in terms of charging, right? But he may up his game, right? He's like, oh, well, you know, if she's going to be doing it for free, and you know, my thing is I'm going to charge. You know, maybe I've got to be better than her, right? And I think that's a great thing, right? You know, because who benefits? Everybody does. Everybody does. He gets better at his thing. The people who are willing to pay, they may get, you know, a really great show, right? And so yeah, I think that kind of competition is probably a great thing. I guess the only thing I would suggest is that you know, maybe, and I mean, you know, this is completely up to you, but maybe don't have your star party on the same night as his. So you know, people can then sort of choose, right? And actually get the best of both worlds, right? So,
and
but
it always starts a fight.
yeah, I suppose it,
probably arrest us too.
well, I suppose it could, but you know, I actually think if, you know, if that kind of thing was done correctly, I think it could actually make everything better, right? I mean, it could make all things better and better, right? I mean, he's he's going to be aware of the fact, that Atta may be doing exactly the same thing that um, um, he's doing. So he's going to have to, change his game or something, right? He's going to have to do something to either, make improvements and make that $5 or whatever it is worthwhile, right? Or he's going to complain. He's going to try to knock you out. He's going to whine. He's going to scream. Who knows, right? Um, so yeah.
Or rage quit, one of the two.
Yeah. So I think all forms are probably okay for myself, right? For myself, I will definitely never ever charge at all. And now, would I participate in a paid star party? Right? I mean, if I was like one of 2 or 3 telescopes that have been hired, to do basically a gig. I don't know. In the case of like the local astronomy association here, all that money is part of fundraising for the club, right? So it doesn't go into the guy's pocket, right? So I guess I would have to consider, where those funds are going.
Okay, I'm not gonna be out there. You might argue also that some audiences might pay closer attention to a paid show too, as someone with a passion to share a passion. I can see both sides. Not a lot of sense, all kidding aside. I already have a wonderful compromise in mind, so we both get what we want. He can charge for the courses he teaches, but not for the billing. If he doesn't go for that, he'll be sorry.
Good for you, Atta. Yeah. No, I like I said, I mean, my attitude is that let's all try and win. This is a big universe, right? This is a big universe. There is room for everyone, right? So if you want to charge and people will pay you, then go for it. Go for it. You know, I'm not going to do that. So, but that's just me. Um, yeah, but I can see this as, I mean, sort of similar to like a musical gig, right? It's like it's almost exactly the same thing, right? I have certain kinds of equipment, right, and certain skills and certain knowledge that I am going to share and or give, right? And in the musical
Now
sense,
my curiosity about Atalata's community and stuff. I want to know if it's even more safer than ours and stuff. Cause like at nighttime, you can't just be outside without people want to be nosy and stuff, want to try to get your stuff, and that can be a little bit crazy too. If you are supposed to be if you're going westbound to Patterson, it's supposed to be the safest city, but most people don't see that now these days.
hmm, yeah, I know for a fact that almost every single time that I used to set up my telescope at home, while I was growing up, right? And I mean, I lived in the city. Almost every single time, somebody, either a car, going by or somebody walking by, they they would they would stop, right? And it's like, what are you doing? What is this thing? It's a lot like I'm DXing with the radio, right? It's like you've got this device, that you're focused on, right? And it's sort of weird looking. I mean, mine, my Dobsonian, right? I mean, it looks like a big big weird looking cannon, right? So it's like, what?
Tim Robinson has a usual point. I am dead against charging the bill, but if everyone donated $1 or $2, the money can be put into making the whole experience better. And the ones that can't, it's not supposed to be discriminated against.
Yeah, yeah, yeah. You know, there are lots of options. You know, lots and lots and lots of options. And you know, I would say, uh, you know, 5 or 10 years ago, I would be like, no, it's wrong to charge, wrong. We're going to knock them out, right?
And
Just
Jay
you know,
Gisler agrees that's just the way it is.
yeah, yeah. But you know, my attitude now is that you know, it's the free market. Let's sort of just let people do what they do, and you know, see what the market decides, right?
Ah,
Um,
so Alaska security guards. That's very nice.
yeah, cool. Yeah. Well, and that makes it really really nice, right? So, but yeah, you'll still get lots of curiosity for sure. Maybe you've noticed that already. That
That
set up your
that's
scope.
why my people may not like me to do some outdoor listening at night, all because of those idiots out there.
Yeah. Well, you know, you do have to be careful, right? Because it just takes one one crazy person, you know, to cause all kinds of trouble. So yeah, yeah. So yeah, you know, so whether to charge or not to charge, I think it's, you know, completely up to the individual. And if you can charge and people are willing to pay, then it's like okie dokie, right? But yeah, you know, for myself, not going to, never have, never will. Would I participate in a in a paid star party? And my answer, you know, being a musician, right, who gets paid for playing music, right? I sort of see that as almost the same thing, almost exactly the same thing.
And
Um,
Tim just hit me on the WhatsApp and telling me he's about to go hit the hay.
hit the hay. All right, Tim. No problemo. It is really really early or really really late there. So yeah, I strongly encourage you to do so. Cheers.
Otto Water says my guess is the free market, which will mean the people will come see my setup because it's free.
Yeah, you know, I mean, if you offer the same quality as his, then yeah, it's a no-brainer that they're going to come see you. And that's why I say, you know, he's going to have to change his game, right? He's going to have to up his game, or he's going to have to, you know, do it for free too. So yeah, you know, but I think no matter what, everybody wins, right? So that's how I see it, at least. So cool. Yep. Atta's quality will be better, she says. I'm not going to dispute that in any way. All right, let's see. It's 2:49 UTC, so we have a little bit more time here. Yeah, and competition is good, right? I mean, if it's done in a civil way, where the goal is to do things better and to be better, then I'm all for competition. Bring it on, right? If competition is to knock down or knock out or degrade or harm your competition, then it's like, well, you know, that's not nice.
I think also the problem is I don't even have a backyard. I have a front yard, and backyard, everything's been all right for me.
Yeah. Well, maybe someday. That's what I always said too. I mean, I've lived in a few places, and yeah, this is probably the first place that I've ever lived where I've had a dark sky. Right? I mean, every other place, I've had to, go somewhere else. Right? I gotta lug everything out to the car. Right? I gotta pack it into the car. I gotta drive it out to the stupid site. Right? I gotta unpack everything, set it all up, do the observing, right? Whatever I'm doing. And I gotta take it all down, pack it into the stupid car again, drive all the way home, unpack it. It's a major, major pain, right? And what I told myself through all of that is that maybe someday I will be able to take my telescope, right, just as it is, right, and just carry it outside. Right? Just carry it outside, put it down on the ground.
Take the second coming of Jesus to say, hey, this is going to stop.
Yeah. Well, you never know. Miracles happen all the time. So you never know. I mean, I consider finding this place pretty miraculous, right? I mean, it just sort of, I mean, we were looking, but this place is absolutely fantastic, right? And so now, right, it's all I have to do is grab my scope, walk outside. And you know what? I even complain about that. It's like, oh man, I got to move all this stuff outside. Oh, that's horrible. And then I think back, right? I think back to when it wasn't like this. And I had nothing, right? I had absolutely nothing. Dreaming of this kind of a situation now, and it's like, yeah, I did it. So keep the dreams going, and be patient, don't give up, and with you got to be the right place at the right time, right? But you also have to be prepared, right? And those are the three legs that sort of spell success. It's a lot of luck. It's a lot of luck, but it's also, you've got to just be prepared. So, and yeah, I am totally spoiled, but that this whole thing was planned, right? I mean, it's not as if this thing just sort of dropped into my lap. I was actively looking for this kind of a location, and this particular spot, yeah, did just sort of drop into my lap, and that's the luck part. And it just so happens that I was ready to grab the golden ring, and here we are. So yay. All right, cool. So I think probably what we should do is we've got a little bit of time left. So let's just do an object of the day. Let's do an NGC object and see what we can find out here. I noticed the archive.org, the astronomy thing, had another huge listing. Something like 67 new papers just came out today, and some pretty interesting things over there too. So, excuse me. So check that out if you haven't already. So I'm going to share my screen. And let's go over to random.org. Let's see, where's there it is. Let's go over to random.org. We'll use, I'll just pop up a new one here.
You still never updated your phone to Chrome 69 yet?
No, I haven't done it yet, Bobby. I am I am just a terribly lazy dude. All right, so there's 7,840 NGC objects. We're going to have random.org choose our NGC object today. All right, you ready? Here we go. Bam! Ooh, 7657. 7657. So let's see. Let's go.
Are we planning on doing an HST on that or just a Sinbad?
Well, you know, let's go over to HST and just sort of see if HST has looked at this yet. But before we do that, let's find out what it is. So let's go over to Sinbad first. And what is it?
Hello to Bagum Megaitis Jr.
Hey there. Astronomy for beginners, astronomy for advanced, astronomy for pros. This astronomy daily live stream is for everyone. So we go from the very beginning stuff, the very beginning things, all the way through to things that just completely fly over everybody's heads. And it's like, what are they even talking about, right? And everything. I like to cover all things astronomical. Yeah, I've got a lot of tabs open. You betcha.
You're trying to get a tab suspender.
Yeah. All right, here we go. So NGC, what is it? 7657. 7657. Probably a galaxy. Okay, so it is a galaxy. Sinbad is calling it interacting galaxies. Okay, well, let's see if HST has looked at this. Now, in all probability, it definitely has not. But let's find out. What was it? 7657. Probably not, but here we go. All right. Nope. Okay, so HST has not looked at it. That's okay. That's all right. That's all right. We will continue with Sinbad. So, yeah, so the NGC numbers are more or less ordered by right ascension, right? So NGC1 is going to have a right ascension around 0 hours or so, and NGC 7840 is going to have right ascension around 23 hours or more, right? I mean, once it gets to 24 hours, it goes back to 0, right? So the fact that this is 7657, right? If I grab my handy dandy calculator here, which every good scientist should have, right? Have within arm's reach is a actual calculator, not the calculator on your computer, right? Nope. Not your calculator on your phone, right? I'm talking about an actual calculator, right? Here, I'll show you this one really quick, right? I've had this one here for over 20 years or so. It's still going. Sometimes, right, it starts showing its age, right? But for some reason, it's always come back. So yeah. So it's all I was going to do was I was going to divide, and I'll share my screen again here. Okay. I was just going to divide 7657 by 7840, and then I'm going to multiply that by 24. And this says that the right ascension should be about 23 hours and 26 minutes, right? If you go by the New General Catalog number, right? that should get you about in the ballpark of right ascension. Now, it's not going to tell you anything about declination, right? So this could be really, really, really south or really, really, really north, somewhere in between. We don't know anything about that. But in terms of right ascension, it should be around 23, 26. And if you look here, wow, that's like incredibly close. It's at 23 hours, 26 minutes, 47 seconds. So yeah, generally speaking, the NGC number isn't usually that accurate. It just so happens it is here. And as far as the declination goes, this is definitely a southern object, right? Declination goes from negative 90 in the south to 0 up to positive 90 in the north. So this is definitely a southern object. So all of us up here in the northern part of the planet, not going to be able to see this at all. But those of you in like Australia, South America, even, yeah, I guess those are the two main land masses. Anywhere sort of south of the equator, you're definitely going to be able to see this guy. But
if you was opt to do it on Stellarium, you should try like at least Rio de Janeiro, right?
Yeah, I mean, you'd be able to see that from Rio, no problem at all, as long as you have a large enough telescope, right? Because I'm looking at the magnitudes here, the brightnesses, and at 14th magnitude, right? That's really, really, really faint. So, so to see this using your own eyes through a telescope, you would need probably, oh wow, at least a 12-inch or a 14-inch telescope. Maybe even like a 16-inch or a 20-inch in order to really, really see it. So, and I think part of the reason is because it's pretty small, right? I mean, it's really, really small. It's fractions of 1 arc minute in size, so it's pretty small. But as you can see by the picture here, it does look like it's some kind of a spiral. Kind of hard to see. I don't think the Sloan Digital Sky Survey went that far south, so we're not going to be able to see it on that. That's too bad. But this is sort of a edge-on spiral. It looks like most spiral galaxies are pretty round, but the reason why you're going to see it like that is because it's set at some kind of an angle, right? So you're seeing it at some angle. You're not seeing it face on. Let's see. So yeah, I guess they're calling this a barred spiral. So somewhere in here is a bar. Ugh, that's a toughie. That's a toughie. Let's open the sky up a little bit and just sort of take a look around. So that's a very, very magnified view of exactly the same galaxy. But do you see how blue it is? How blue it is? That's sort of indicative of sort of young hot stars, right? So this might be a relatively young galaxy, but judging by its size, right, it's probably pretty far away. But it's got some, at least as far as the line of sight goes, right, it's got a couple of neighbors. It's got this one here. This guy looks like almost a face-on spiral, although he's got some interesting action here, right? But there's a nice bar here. See this straight part, and then it sort of trails off with these spiral arms, except for this one chunk. Now, what is going on there? I don't know. We're going to have to study it. Anyway, where's this other guy? Here he is. Okay, so here's our object of the night, at least. So yeah, let's zoom out a little bit, just sort of look around in the neighborhood. Not really seeing anything else. Not too much else. Just a bunch of stars, which is nice enough, right? But the cool thing here, right, is that every star that you see, every single star in this, right, all of these things, except for the galaxies, right, these fuzzy dudes here, right, everything else in this field of view is a star in our galaxy, right? So we're sort of looking through this mass of stars that makes up the Milky Way. We're looking through all of that to sort of these background galaxies.
Now, Archewada said the bluer a star, the hotter it is. But
Yeah.
she has a hard time with that conceptuality.
Okay. Yeah. That's just a thing that you're going to have to sort of learn. Look up the Hertzsprung-Russell diagram. I'll let me type that in the chat. Hertzsprung. I think that's how you spell it. Russell diagram. Let's in fact let's go over there and find out. Hertzsprung-Russell diagram. So here we go. Right? So the more luminous and more massive stars tend to be bluer and hotter. And the cooler stars, less massive sometimes, at least the cooler stars tend to be red, right? And our sun is sort of a yellow giant. Its temperature, at least according to the current thought.
There's in color, temperature, and black body radiation.
Yeah, yeah. Here's another kind of cool looking diagram of the same thing. Oh, can't be reached. Oh well. Let's see. Is there any others? Yeah, there's lots of these examples, right? But yeah, if you go for the Hertzsprung-Russell diagram, you can sort of go from there. Atta, you will go get it. Here we go. Yeah, it's a lot of things in astronomy are sort of counterintuitive, right? Magnitude scale, where the larger the number is, the fainter the object is. It's just counterintuitive, and I don't really know why it is done that way, but it is, right? So it's one of those things that you just sort of definitely investigate it, right? I mean, it's sort of an interesting story as to how all these things came about, and this day of age, right? You can find out exactly, why the magnitude scale is backwards, right? At least sort of intuitively backwards. Once you understand it, it actually makes a lot of sense. So and that goes for a lot of things, right? In terms of color and temperature, exactly the same thing. It's like shouldn't the hotter stars be red and the cooler stars be blue? No, it's the other way around. So it's just to confuse everybody, right? Yeah.
That's NGC 7657, right?
It is 7657. Correct. All right. Let's go back really quick and just sort of take a look and see what else is here. So here's a few other names for it. All right, not too many. This object, I mean, obviously, oh yeah, look at that. Only 11 papers reference this object. So yeah, this is this is one of those objects that has just not had a lot of attention paid to it for one reason or another. Opportunity, for somebody, right? Let's see. They do have some velocity measurements, so let's take a look at that. Let's see how this thing is moving in the sky. Oh, where is it? There they are. So at least according to this galaxy is moving away from us, or we and it are moving away from one another at about 3,200 kilometers per second. All right, so that's pretty fast. That's pretty fast. I sort of dare say that this object is probably pretty far away too, maybe a couple of hundred light years at least. The fact that you can still see structure here, as bad as it is, means that it's not incredibly far away, right? Because if it was really, really far away, it would just be, just like an amorphous little blob, right? But, we're seeing some interesting structures here, right? There's this big, bright region here, which could be a foreground star, could be, but it actually could be a part of that galaxy, some kind of active region, possible. But, we're seeing a spiral arm here, and maybe a little bit of a spiral arm here. Let's zoom in a little bit. Some structure here. We're definitely seeing, a central bulge. So, the fact that we can see, some kinds of things in this means that it can't really be incredibly far away. So, there isn't any information here, right? There's no information on distances at all. This, I'm not quite sure what this is. I don't think this is parallax. I'm not quite sure what this is. But yeah, there aren't any distance measurements here. So, we may not know how far away this thing is, right? We may not have any accurate kinds of measurements. Now, if we ever observe like a supernova in this, well, we might be able to use that supernova as at least one of the ways to make a relatively educated guess. But we got to be monitoring it to do that. And I doubt that we are. I doubt that we are. So let's look at the papers really quick, and then we'll get out of here. Let's see if there's anything specific to this object. I doubt it. Yeah. See, these are all going to be catalogs. So this poor little object has just never really been studied very carefully. Yeah, it's all catalogs. Catalogs. So, a catalog looks for particular things, right? Let's see, is there a good one here? Yeah, this catalog, right, was just measuring redshift, right, which is, at least as the story goes, right, it's sort of a way of actually measuring, if nothing else, how fast it's moving away from us. That can also give us a little bit of an idea maybe about how far away it is, maybe. But yeah, it is just a catalog, though. There's just nothing specific about this poor little galaxy. 78, 76, 57. See, I don't even remember it. So IRAS was a infrared space telescope. So back in 2009, they did that. Um, let's just look at one of these and just sort of see if it references this object at all, because I've noticed that a lot of these references don't actually reference the galaxy here. Now, look, they've got a catalog of 125,000 galaxies. So, wow, that's pretty
A blue
impressive.
band gets a bit blue when cold and red when hot, but most anything else is a molten puddle long before it gets blue.
Yeah, yeah, that's absolutely true. And they're actually talking. When it comes to colors and stuff, we're actually talking about objects that that are called black body objects, and that has a sort of a specific definition. They aren't black. It's just that they emit at all wavelengths, but some wavelengths they emit more light. So a very very hot object um, is actually going to emit in the blue, um, and that way, and a cooler object is going to just emit more in the red. It's not as if they only emit light in red or blue or yellow, right? It's just that the majority of their light um, is put out at those wavelengths. So now let's just sort of look at this paper here if we can. The 6DF Galaxy Survey, Data Release 3. So again, all of these papers are just this huge effort, right? I mean, look at all these authors, right? From multiple, many institutions. Australia, United Kingdom, here's the United States, Australia, South Africa. Here, I'll zoom in a little bit here. So, collaborations are great, but it actually, makes it even more work, right? Because you have to, you've got to get all these guys talking to one another too. So, but yeah, they measured redshifts of wow, over 100,000 galaxies. Multiplexing spectrographs. Yeah. So, and they were looking at basically just pretty bright objects too, right? I mean, K and H and J are infrared magnitudes, but that's pretty bright. It's pretty bright. So they were just looking at the brighter ones here. So yeah, I'm not going to get into a lot of this, but all these papers are, as far as I'm concerned, really interesting reads, because they go through their methodology, they explain the instrumentation, they talk about how they collected the data, where they looked, right? How they looked, and then how they took that data and processed it, did some kind of an analysis on it. It's fantastic, right? It's absolutely fantastic. So yeah, that many objects, they can actually do stats on it. They can get these histograms of redshift, which is this z value here, and they can count the number of galaxies that have that particular redshift. And interesting, they're finding little spikes and all kinds of structure in here, right? All kinds, just amazing, right? Pretty amazing. So yeah, this is a data release, right? And we can probably actually, yeah, there it is. Went right to the website, right? And if we want any of this data, right, here it is. Here it is. We have access. Anybody has got access to this. And if you know what you're doing, right, you can take this data, do your own research, whatever, right? It's very cool. It's very, very cool. Uh-oh, did I killed it there. All right, well, let's just flip through to the end here. Don't want to take up too much more time because I am trying to be moderately mindful of the time. But you know, this is astronomy, so for me, I could go, you know, I could go on and on and on. It's hard to stop. You know, once I get going, it's like, oh man, I just want to keep looking at all this stuff and thinking about it. And I like these kinds of surveys because there's lots of data, right? And I'm a total nerd, right, when it comes to data, because you know, not only is there useful information, right, in all these wiggles and all of this, right, they're actually identifying elements, right? Silicon 2, there's H alpha. Here's, I think that says sodium, Na. It's kind of hard to see there, but I guess they're identifying magnesium, oxygen, hydrogen. I don't know what this G is. So yeah, you know, these are the hydrogen lines, right? H alpha, H beta, yeah, all of that. Kind of cool. Let's see over here. So there's Lyman alpha. So that's another hydrogen line. Silicon, carbon. Yeah, see, I mean, it's like, wow, is that really there? I don't know. That's kind of hard. That's kind of hard. But yeah, so awesome stuff, of course. Let's see, what else do they have here? Okay, so yeah, so here's the sort of the description of the database that you have access to and what kinds of information you've got access to. Very cool. It looks like most of this information is spectra, though, right? It's not really images. So, you know, spectroscopy, there's a lot more information in a spectrum. Well, can I say that? There, you know, there is different kinds of information inside of a spectrum compared, you know, to like a picture. Is there more? It sort of depends on what you're looking for, I guess, right? But spectra are very, very rich in terms of data. Yeah. So they're looking at structures. Very cool. Huh. Kind of neat. What does the caption say? So the distribution of galaxies. Okay, cool. So yeah, you know, the distribution of galaxies is not uniform, right? They tend to clump up and form these structures, right? Now there are, you know, galaxies sort of spread over everywhere, but there's gaps, right? There's these big holes, and as I said, you know, there's these clumps, Not quite sure what the colors mean. Redshift. Okay. All right. So that's a measure of redshift. And again, you can sort of translate that to distance, sort of, right? So the purpley ones here are close to us, and the red things here are further away. So that sort of gives you a sense of depth. So pretty cool, pretty cool, kind of neat. Yeah, see, they're actually pointing out some of the clusters. Sculptor down here, Pavo Indus. Here's the normal wall. I don't think I've ever heard of the normal wall. Huh. Columba cluster, Fornax cluster there. Yeah, cool. That is sweet. Okay, so I guess this was in the south, right? I guess if I'm reading this right, this is sort of like a declination here. So these were the southern ones. Here's the northern ones that they found. And again, Centaur. Oh, okay. Well, it can't be incredibly north because that's Centaurus right there. So yeah, I'm not quite sure what these coordinates are, but pretty interesting, right? That on large scales, right? We see galaxies clustering in these groups and forming these long chains and these gaps, kind of cool, kind of cool. And you can only get this kind of information, right, if you look at 100,000 galaxies, right? I mean, if you look at a couple of them, you're not going to see this, right? If you get a whole bunch, stack them all up, yeah, you start to understand or at least get an idea of what the structure of the universe is, right? These are on cosmological scales now. So, yeah. And these are just the nearby ones, too. I mean, I think I was seeing a redshift, what, out to 0.2, which is, I don't remember how exactly that translates, but that's not really all that far. That might be, 3 or 4 or 500 million light years away or so. So I mean that's far, you know, but it's not 10 billion light years away, right? So these are actually just sort of the nearby galaxies too. So lots of galaxies, lots of galaxies. All right. Well, wow, I've gone way over time. So I'm going to stop sharing and I'm going to bid you all farewell. So thanks for coming in. I'm going to check the chat one more time.
And you kind of like a bit low on the sound too.
Low on the sound?
Yeah.
Oh, okay. Yeah, I don't know. I've got myself turned up relatively high, so maybe it's just that I wasn't speaking exactly into the microphone here. So, well, thanks. I appreciate that kind of feedback because yeah, I want to make sure that that you can hear me okay. So, all right. Well, I guess I'm going to get out of here for now. Like I said, thanks everybody for coming in. I really, really appreciate this. This is me just sharing a passion, right? I like to think and talk astronomy as much as I possibly can, and I think that this is a really, really awesome and fun way, to share that passion. And that's all I'm doing. That's all I'm doing. We follow our noses here. Don't really have any kind of set agenda. Pretty casual and fun. But I'm glad you like it. I'm glad you keep coming back. That makes me feel good. And because I like to share these kinds of things, these kinds of experiences. And I like to, share a little bit about my process of learning as well, because I'm looking at these things with you, sort of for the first time, and usually what I'll do, right, is I'll just sit here and I'll read things and I'll think about stuff. So it's all I'm doing differently here is that I'm just sort of thinking out loud. So I'm just sort of verbalizing exactly what I'd be thinking about anyway, and I think it's fun. Um, and um, I don't I don't see anybody else doing this. So I'm filling a little bit of a niche, and this definitely probably isn't for everyone. But I'm not trying to cast a net here, right? Trying to throw out a broad thing. What I'm trying to do is harpoon, right? It's like there he is. Bam. Got him. So, okay, I will let you go. As I said, uh, tomorrow's live stream, there's a 50-50 chance that it's not going to happen. If it doesn't, I will definitely let you know, right? I mean, I'll tweet it, I'll put it on the Discord, and I'll probably make a short video and post that here on YouTube. But right now, there's sort of a 50-50 chance. Um, don't know. Don't know. I will definitely know more in about 22 hours or so. So, okay, well, um, I guess I will see you when I see you. It'll either be in one spin or two spins of this tiny, tiny little planet that we're on. Okay. Take care, everybody. I will see you. I will see you later. Bye.
Later.